Prepare to embark on an extraordinary cosmic journey as we delve into the enigmatic depths of the Oort Cloud, a realm teeming with mysteries and cosmic wonders that will leave you awe-inspired and questioning the very fabric of our universe. Brace yourself for an odyssey into the uncharted territories of space, where the boundaries of human knowledge are pushed to their limits. Get ready to unlock the cosmic enigma that is the Oort Cloud, a celestial spectacle that will forever change the way you perceive our place in the grand tapestry of the cosmos. The Oort Cloud. The Oort Cloud, sometimes called the opaque Oort Cloud, is a theoretical concept of a cloud of predominantly icy planetesimals proposed to surround the Sun at distances ranging from 2,000 to 200,000 AU, 0.03 to 3.2 light-years. It is first described in 1950 by the Dutch astronomer Jan Oort. It is divided into two regions, a disc-shaped inner Oort cloud, or Hills cloud, and a spherical outer Oort cloud. Both regions lie beyond the heliosphere and are in interstellar space. The Kuiper belt, the scattered disk, and the detached objects, the other three reservoirs of trans-Neptunian objects, are less than 1,000th as far from the Sun as the Oort cloud. The outer limit. The outer limit of the Oort cloud defines the cosmographic boundary of the solar system and the extent of the Sun's heliosphere. The outer Oort cloud is only loosely bound to the solar system, and thus is easily affected by the gravitational pull both of passing stars and of the Milky Way itself. These forces occasionally dislodge comets from their orbits within the cloud and send them toward the inner solar system. Based on their orbits, most of the short-period comets may come from the scattered disk, but some short-period comets may have originated from the Oort cloud. Astronomers conjecture that the matter composing the Oort cloud formed closer to the Sun and was scattered far into space by the gravitational effects of the giant planets early in the solar system's evolution. Although no confirmed direct observations of the Oort cloud have been made, it may be the source that replenishes most long-period and Halley-type comets entering the inner solar system, and many of the Centaurs and Jupiter family comets as well. Structure and composition. The Oort cloud is thought to occupy a vast space from somewhere between 2,000 and 5,000 AU, 0.03 and 0.08 Li, to as far as 50,000 AU, 0.79 Li, from the Sun. Some estimates place the outer boundary at between 100,000 and 200,000 AU, 1.58 and 3.16 Li. 9. The region can be subdivided into a spherical outer Oort cloud of 20,000 to 50,000 AU, 0.32 to 0.79 Li, and a torus-shaped inner Oort cloud of 2,000 to 20,000 AU, 0.03 to 0.32 Li. The outer cloud is only weakly bound to the Sun and supplies the long-period, and possibly Halley-type, comets inside the orbit of Neptune. The inner Oort cloud is also known as the Hills cloud, named after Jack G. Hills, who proposed its existence in 1981. Models predict that the inner cloud should have tens or hundreds of times as many cometary nuclei as the outer halo. It is seen as a possible source of new comets to resupply the tenuous outer cloud as the latter's numbers are gradually depleted. The Hills cloud explains the continued existence of the Oort cloud after billions of years. Origin. The Oort cloud is thought to have developed after the formation of planets from the primordial protoplanetary disk approximately 4.6 billion years ago. The most widely accepted hypothesis is that the Oort cloud's objects initially coalesced much closer to the Sun as part of the same process that formed the planets and minor planets. After formation, strong gravitational interactions with young gas giants, such as Jupiter, scattered the objects into extremely wide elliptical or parabolic orbits that were subsequently modified by perturbations from passing stars and giant molecular clouds into long-lived orbits detached from the gas giant region. Recent research has been cited by NASA hypothesizing that a large number of Oort cloud objects are the product of an exchange of materials between the Sun and its sibling stars as they formed and drifted apart, and it is suggested that many, possibly the majority, of Oort cloud objects did not form near the Sun. Simulations of the evolution of the Oort cloud from the beginnings of the solar system to the present suggest that the cloud's mass peaked around 800 million years after formation, as the pace of accretion and collisions slowed and depletion began to overtake supply. Comets. Comets are thought to have two separate points of origin in the solar system. Short-period comets, those with orbits of up to 200 years, are generally accepted to have emerged from either the Kuiper belt or the scattered disk, which are two linked flat disks of icy debris beyond Neptune's orbit at 30°, and jointly extending out beyond 100°, from the Sun. Very long-period comets, such as C/1999 F1 Catalina, whose orbits last for millions of years, are thought to originate directly from the outer Oort cloud. Other comets modeled to have come directly from the outer Oort cloud include C/2006 P1, Mignaut, C/2010 X1, Elenin, Comet ISON, C/2013 A1, Siding Spring, C/2017 K2, and C/2017 T2, PANSDARRS. The orbits within the Kuiper belt are relatively stable, and so very few comets are thought to originate there. The scattered disk, however, is dynamically active and is far more likely to be the place of origin for comets. Comets pass from the scattered disk into the realm of the outer planets, becoming what are known as centaurs. These centaurs are then sent farther inward to become short-period comets. Stellar perturbations and stellar companion hypotheses. Besides the galactic tide, the main trigger for sending comets into the inner solar system is thought to be an interaction between the Sun's Oort cloud and the gravitational fields of nearby stars 4, or giant molecular clouds. The orbit of the Sun through the plane of the Milky Way sometimes brings it in relative proximity to other stellar systems. For example, it is hypothesized that 70,000 years ago, perhaps Scholz's star passed through the outer Oort cloud, although its low mass and high relative velocity limited its effect. During the next 10 million years, the known star with the greatest possibility of perturbing the Oort cloud is Gliese 710. This process could also scatter Oort cloud objects out of the ecliptic plane, potentially also explaining its spherical distribution. As we journeyed through the depths of space and explored the mysteries of the Oort cloud, we can't help but be captivated by the awe-inspiring wonders that lie beyond our solar system. The Oort cloud, with its vast reservoir of comets and icy objects, offers a glimpse into the far reaches of our cosmic neighborhood, where the boundaries of our knowledge are stretched to their limits. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.